easy day. Today is 5/13/21, and we're going to be naming triangles. Guess what? There's really no work for this. There's no work for naming triangles. There's no like solve an equation like yesterday. So it's all vocabulary. So yay or nay, I mean, it's vocabulary. So it's kind of like English more than math. All right, naming triangles. So there's two ways to name a triangle. The first way you can name a triangle is based on the angles. So you have an acute triangle, a right triangle, and obtuse triangle. I kind of said a little bit of this before your map test. The second way you can name them, actually before I do that, so to be an acute triangle, all three angles are acute. All three angles are acute, all of them. Not one, not two, but all three angles. If all three angles are acute, then you have an acute triangle. A right triangle only has one 90-degree angle. Just one. So here, all three have to be acute. Here, you just need one right angle, one 90-degree angle to be called a right. And in obtuse, you just need one obtuse angle to be called an obtuse triangle. Okay? Obtuse. Okay, I think these come pretty natural to you guys because it makes sense. You've heard and learned about acute, right, and obtuse angles. So a triangle is just very similar to that. If all the angles are acute, then you call the whole thing acute. If one of the angle is right, you call it right, so on and so forth. Because mathematically, you can't draw a triangle that has two 90-degree angles. You can't draw a triangle that has two obtuse angles. It just doesn't make a triangle. Okay? Now, the second way you can name triangles are by the sides. Does anybody know the three types of triangles based on sides? Based on sides. Does anybody know any of the vocabulary? So that's based on angles. Now we're going to base it on sides. So it's brand new there's three different ways to name a triangle based on the sides, not the angles.
Equivalent?
Close. Very close. It's called equilateral. That's the first one. Equilateral. So equilateral triangle. So equilateral. So how many sides do you think are equal in an equilateral triangle? Take a wild guess. Yes, Elizabeth. So equilateral triangle has three equal sides. So it looks something like this. This is like 1 centimeter, 1 centimeter, and 1 centimeter. So this is called an equilateral triangle because all three sides are equal. And we're talking about triangles, so three sides. So all sides are equal. So that is what you call an equilateral triangle. To me, that's the easiest one to remember because it kind of has the word equal in it. So, okay, if all the sides are equal, then it's called an equilateral triangle. Okay? All right. The next one is called isosceles. Isosceles triangle. Isosceles triangle. An isosceles triangle has two equal sides, because we're looking at the sides. We're not looking at the angles, we're looking at the sides. So an isosceles triangle has two equal sides. To me, that looks kind of like a Christmas tree. So, type of thing. Like, I always visualize drawing a Christmas tree. So this is like 5 centimeters, this is 5 centimeters, and then like this is 2 centimeters. So an isosceles triangle has two equal sides. Two of the sides are equal, and the third side is like a different number. That is what we call isosceles. Here's how I remember it. When you draw an eye, you want the top and the bottom to be equal, right? So the eye has two equal lengths. Usually the middle one is different than the two lines on the top. Literally, that's how I remember the word isosceles. Isosceles means two equal sides because the eye has, at the top and the bottom lines are equal. So that's how I remember it. Why? Because the third word is like totally weird. The third way to name a triangle by its sides, is called a scalene. A scalene triangle has no equal sides. No equal sides. Zero equal sides. So usually if I draw an obtuse angle, I usually get a pretty good isosceles there. So this is like 4, this is 7, and maybe like this is 10. So a scalene triangle has no equal sides. Okay? An isosceles triangle has two equal sides, and an equilateral has all equal sides. So you have 3 different types of triangles out in the world. Actually, there's more, but whatever. So equilateral, a scalene, and isosceles. Okay? Some of you might have know that already. Some of you may have heard it before, but forgot which one's which. Maybe some of you, this is the first day you've ever heard of these words. Cool. We're all different, but you will be needing these when you go into geometry. Why do you need to know this? Because there are certain things that only happen in an equilateral triangle. There's certain things that happen in isosceles triangle. And those certain things that you'll be learning as you progress in math help you solve math problems, right? So for example, here's something that you need to know. You actually don't really need to know, but it's good to have like in the back of your head. So when the teacher asks you this in geometry, you say it and then you look all smart because you're just like, oh, you know already. In equilateral triangle, all the angles will always be 60 degrees. Always. If you have an equilateral triangle, all your angles will be 100% 60 degrees. There is no other combination for equilateral triangle. Always, 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 your angles are 60 degrees. Always. There is only one type of equilateral triangle. That's an acute triangle. You cannot have an equilateral right. You cannot have an equilateral obtuse. Equilateral will always be acute. So that's like put that in the back of your brain. Isosceles, if you have two sides that are equal, guess what? You have two angles that are equal. Isosceles has two equal angles and two equal sides, okay? So these two angles will be equal to each other, these two angles. The bottom angles will be equal to each other. That's like knowledge that you'll need when you get into geometry. Why? Because then you can solve equations, knowing that they're equal to each other. You'll use that knowledge. And by the time you get to that knowledge is just like, oh, that's kindergarten knowledge. For you guys, might make sense to you right now. Might go like, okay, I get it. Not really sure what to do with it, but I understand. Two sides and two angles. Got it. All of these angles are 60 degrees. Okay, cool. I don't know if I'm going to use it today. No, but you will be using it later on in your math career. All right. So in order to name a triangle, you need like one word from the top list and one word from the bottom list. It's kind of like giving it like a first name and a last name, okay? So for example, if I were to give you this triangle, yes, copy this down, and I just did that, hopefully your brain automatically knows at least one of the names, right? Just by giving you that little red box right there, you know that the first, let's call it the first name. The first name is a right? So if I look at this, boom, automatically, it's a right. Now, let's give it some other name. So I don't know if it's isosceles or scale. Let me see. 1, 2, 3, 4, 5 boxes. 1, 2, 3, 4, 5. Yeah, I guess I did a 5, 5. Let's do 9 right there. So yeah, I would guess I would call this a right because of the angle. And then the last name or the middle name, however you want to call it, is isosceles. And you can call it, the last name could be triangle. Everyone's named triangle in this family. So here is the proper name of this triangle. It is called a right isosceles triangle. A right isosceles triangle. Now, could you name it isosceles right? Yes, you can move these two names around. You can interchange them, okay? There's no one right way to write it. Like, oh no, first is the angles, then the sides. No. So, but what you have to understand as a 7th grader is this word comes from the angles and this word comes from the sides. Okay? As a 7th grader, you have to understand that. Where do I get this word from? Because it has a right angle. Where do I get this word from? Is because it has 2 equal sides. Okay? Are we okay? All right. You're drawing these to the best of your ability. Sometimes they come out pretty good. Sometimes they really don't look like what you need them to look like. And that's fine. Let's do 5 centimeters, 5, and 5. So based on the information right there, I go this side's 5, this side's 5, this side's 5. So they're all of the sides are 5. So you know that it is an equilateral. Now, I told you before, all equilaterals are always acute. All of these angles are acute. What does that mean? Well, that means that they're less than 90 degrees. So sometimes it's hard for students to understand like if I cover the triangle up, does that look like acute, right, or obtuse? Well, that looks really small, Miss Molly, so it's acute. Yep. Over here, what about that angle? Well, that looks acute too, right? Less than 90. Okay. Now go to the top. What does that angle look like? Oh, it also looks like less than 90. Yep, all of them are less than 90 because they have to be. Equilateral, acute equilateral triangle. Again, you can call it equilateral acute. There's no I'm not going to take off points because you changed the order. I mean, next year, next period, I can call it equilateral acute. I like to change it up. All right. All right. So what would we call this angle? Measures 15, 11, and 7. Yep. So you know it's called, or you should know it's called scalene because none of the sides are equal. None of the sides are equal, so scalene. Now you look at the angles. Some of you can look at the angles and know it. Others, like if you cover it up, this angle is acute, right? I'm going to put a little A for acute. How cute is that? Look a little tiny. So it's cute. That angle on top right here, super acute, right? I'll write a little A for acute, a little super small. And then this angle down here, right? There's my angle. That one's totally 100% obtuse. So this one's the obtuse angle. Well, obtuse beats out everybody. Even though you have two acute angles, you have one obtuse. And with that one obtuse, they'll call the whole thing obtuse. So this is an obtuse scalene triangle. Are there any questions? Okay, I want to show you guys something. I didn't have time to show you this yesterday, but I'm going to show it to you today. Okay, I'm going to take a piece of paper. And you know how yesterday I taught you that the triangle sum theorem says when you add the three angles, it equals 180. Now, 180 degrees looks like a straight line. We learned that back in like way before circles. Let me see, when did we learn? Oh, look, I did teach you that. I think I taught you that. Okay, here, a straight angle measures 180. Do you guys see that? 180. So, show you here. This is a triangle, right? It's a right triangle. Looks kind of like isosceles. So what happens is if you were to cut up the angles in a triangle and lay them together, all the angles in the triangle, it gives you a straight line. Let me do that one more time. So here I have a triangle. So I have the green angle, number 1, the red angle, number 2, and the blue angle, number 3, right? So I have this triangle, and yesterday you learned that if you add up these 3 angles, it equals 180. And I wanted to show you that it really does. So I'm going to cut each angle out. Let's do that. And if I put the angles together, like so, gives you a straight line. Straight lines equal 180. So it's like magic. So if you take a triangle and you cut up all the angles and you lay them straight, it equals 180 degrees, meaning it's a straight line. So this is what you were doing yesterday. You were proving that triangles equal 180. You didn't realize is that literally it does work. Cut up a piece of paper, put them together like so. If you have steady hands, it equals 180 degrees. Like magic. All right, there's my magic trick of the year. All right. Any questions on scalene, isosceles, equilateral